of any involved quality majors and manufacturing. Quality majors generally go to quality assurance end, and screen planning, check out what the planners are doing, and generally check out the engineering and the technicians. Manufacturing end are the people that write the planning, deal with the engineers, management, and technicians, and combine the whole package together. What I've done is create a film to demonstrate that point and basically simulate what goes on in industry. So sit back, enjoy the film. Everyone. Planning is usually done on a computer like this, or maybe a mainframe computer in most large industries. Planning for most people is basically the same whether you're in aerospace or a job shop, things like that, unless you're into facilities or city planning, which really doesn't have anything to do with our major. Mostly what I'll be concentrating on is planning related to manufacturing and quality majors. There's a lot of steps that need to be taken to do planning. There's the initial design, consulting with the engineers, the management, and the customers. And then there's the planning decision activities, where it will be built, what parts will be bought, what parts will be made in-house, and items like that. After those have been done, then the planning department will start working into things like tooling, procurement of parts, and writing the actual planning itself, dealing with the engineers and the technicians hand in hand. For demonstration purposes, what we've done is we've selected the installation of a 3-inch lift kit and large tires and rims on Toyota full-wheel drive. It's basically the same as what you'd see in any aerospace company. It's just that they won't let us bring a camera inside, so we had to make do. What we did, as we started out, is we figured we are the customers, we are the management, we are the technicians. We're going to be everything but the planners in this. We started out with, what do we want? First of all, we started out with catalogs, and with the catalogs we decided that, okay, we're going to go with the Dixie-Pack Rancho suspension system, which is really not important right now, except for we had to go through a dealer that had a good reputation, carried a quality product at a reasonable price, which is something that a planner, production control, and purchasing department all need to keep in mind and work hand in hand on. After we chose the suspension, we dealt with the vendor to get satisfactory equipment, and then we started on our installation. The planning document itself they gave us was a little bit more than this. This is not what we would really call quality planning, but it's cheap. Somebody did not have to spend a lot of time on this. Instead, they gave us our planning, installation instructions. What installation instructions are, along with the red warning signs and things like that, is how to do it. It's the communications between the engineer and the technician. A quality planning document will contain step-by-step instructions on everything that needs to be done. After the installation is done, then follow-up is required, maybe engineering modifications, things like that. There's all sorts of variables that are involved that a planner must keep involved with in order to keep the integrity of the project and in order to keep the customer management and the engineering staff happy. So now that we've got our planning, we've got our parts, we've got our facilities, let's get to work. Here we have our project vehicle for the 3-inch lift with the oversized tires and rims. What we've done is we've laid out all the parts and the tools required. The planning document itself should indicate what tools are required for the installation. On the installation instructions they gave us, they did include the tools required, such as a floor jack, a drill, and not necessarily a hammer, but it does come in handy. Production control, or the vendor, has supplied us with a kit with all the necessary parts. Now this is typical in aerospace also. Quality control would have the function of saying, okay, is this part good enough? Is this what we really want to do to keep the integrity of the overall product? The screw, for instance, made out of standard garbage metal. Why didn't we get titanium? Why didn't we get it a C6 or something like that? Well, mainly because of cost. which is something that engineering, planning, and quality have to combine together with the customer to see what the requirements are. Over on this side of the garage, we have the tires that we chose for the lift. The problem that we have here is that we only have 4 tires. For a complete installation, 5 tires are really needed. 4, obviously, for the vehicle to roll on, and 1 for a spare since the stock tires are too small. A decision that a planner or a customer would have to make in a case like this is, do we go ahead and install the 4 tires and just worry about getting the spare later, or do we wait and we do a complete installation job all at once? What we've decided in this case is, hey, what the hell, let's just go put on the tires so we can go off-roading. So let's get to work. Obviously, in some cases, the engineer doesn't talk to the technicians. This is where a planner comes in. This is where a planner and quality and the engineering staff and the technicians all get together and they say, what's the best way to do this? What's the best way with the best tools in the most efficient time to create a quality product? In this case, we're installing a stop against the frame to keep the springs from coming all the way up. Now in the instructions here it says drill 2 holes. So what we've done is we've marked 2 locations for the holes to match. And something like a satellite or an aircraft, there may be an inspection point because this is an irreversible process. In our case, we don't have inspection, so we just drill. And drill, and drill, and drill. With hard to reach places because nobody talks about combining engineering and technical skills together. Springs in the way. Well, the engineers failed to realize that frames are made of chrome moly stainless spring steel, which can't be drilled by anything other than a laser. Now the whole idea here is just to attach this piece of metal. In the case of a spacecraft or an aircraft, for instance, maybe it has more crucial meaning to the overall product, the integrity of the product. Maybe it relates to something else. This is where engineering, the planner, and the technician need to come up with an engineering change. Planner, with all his infinite wisdom, have the right idea, it's just not working. This is part of the follow-up that involves quality and manufacturing. What they need to do is come up with a better method to perform this operation, maintain the integrity of the spacecraft or the aircraft, and keep the customer happy with a high standard of quality. In our case here, it really doesn't make much difference. So we'll just do whatever works. The right tools for the right job. Integrity. In unimpaired condition, firm adherence to a code, or the quality or state of being complete or undivided. You notice that I use the word integrity quite a bit in this film because integrity is important for a planner, for technicians, for engineering. You also notice that I mentioned a lot about people working together. The quality, engineering, management, customers, and the planners who put the whole thing together. In our example that we showed you here tonight, what has happened is, well, now it's daytime. That's because we didn't have proper tooling. We tried all the planning we could, but since we did have a problem, well, we worked all night on this puppy and we finally got it finished. So, special thanks to Dennis Rain for handling the camera and helping me install the kit last night. And we're going to go out and give it a try.